All right. So now that we've looked at the low PO2 region and construct and verified the slopes and looked at it and compared the concentrations, we're going to look at the high PO2 region. And to do that, we're going to take that mass action expression oxidation that we derived in that portion uh, in the earlier module. So we had the metal vacancies times the holes squared, and then PO2 to the minus 1/2. And we also applied the Brouwer approximation, and we saw that this was valid if these are the two main species, electron holes and metal vacancies. So we're going to do the same thing here, and we're going to try to look at the slope, just like we did before, to try to see if what the slopes are for the high PO2 region using looking at metal vacancies and electron holes. So that's what I want you to do here. So this is going to be a quiz question. So see if you can determine the slopes of the concentrations for the high PO2. So that means metal vacancies as well as electron holes, and see if you can determine the slopes for the Brouwer diagram in that region. And so you're going to want to again look at the figure 6.6a in your book to compare and see if you got the right thing. So pause the video here, answer that in the quiz, and then come back and we will see if you get the same results and got what we had in the textbook. All right, so let's go ahead and look at the solutions for that. So again, we're looking for the log concentration of metal vacancies and the log concentration of electron holes versus log PO2 to see what the slopes are of the Brouwer diagram. So we start with this expression, and again, just like we did before, we're going to apply this so that we can, instead of having both concentrations here, we can isolate one by using this expression. So we'll plug this expression into here. And again, it will look similar to what we did before, only we'll have metal vacancies, and that will all be squared. And if we incorporate that, that'll be 4 times the metal vacancy concentration cubed, PO2 to the minus 1/2. And so rearranging this expression to solve for this, we'll get that Vm cubed is equal to 1/4 K ox PO2 to the 1/2. Sorry about that. This should be 1/2. So sorry, I skipped a step here. Let's go ahead and I solve for this 1/2 O2, and then this was, yes, 1/2. I just wanted to make sure I had everything correct there. So this is PO2 to the 1/2. Sorry for the confusion there. Okay, and then we take the cube root of this, and again we will get this, kind of leave everything as just what it appears, because this will all be a constant. And then this, the incorporation of the cube root, the 1/3, means that we have PO2 to the 1/6. So you see this expression's shaping up to be very similar to the reduction or the low PO2 side, the main difference being the sign here. This was a negative 1/6 before, this is a positive 1/6 here. That's the main difference. All right, and then again, the Brouwer diagram is in terms of logs, so we're going to take the log of both sides, and this is mostly to linearize everything. One third plus the other part of the constant k ox to the 1/3, and then log PO2 to the 1/6. And again, this is a constant portion of it, and so if we just look at the proportionality for the slope, we see that that is metal vacancies, log of the metal vacancy concentration is equal or is proportional to 1/6 the log of PO2. And so the 1/6, the positive 1/6, is the slope here for the metal vacancy concentration. And if we do a similar derivation for the log of the P, or the electron holes, right, we'll get that that is also proportional to 1/6 log PO2, just like the other one. And just like before, the main difference will be this factor of 2. And so that will be kind of out front here. We'll have a 2 out here. So the only difference between these two lines will be a factor log 2 shift, where this is slightly higher than this. So let's verify this, and let's go back to the Brouwer diagram and see if this is what we get. The plus 1/6 slope, and then the difference of the log 2 again. All right, so we're back here looking at the Brouwer diagram. This is for 6.6a. Now we're looking at the high PO2 region, and we were looking at the electron holes and metal vacancies, so these two lines up here. So them being at the highest log concentration, again, that implies that our assumption is that they have the highest concentration and everything else is kind of minor species. And we see here that the slope is listed as 1/6 positive, and so we see that the concentration of holes and metal vacancies increases with increasing log PO2, which is what we expect. And again, both the slopes are the same as what we calculated. And the only difference, which is minor, is that the hole concentration is slightly above by, again, that log 2 factor in the constant. But it's a constant shift. The slopes are the same. Okay, so far we've looked at the major species here in the low PO2 and major species here in the high PO2. And next we're going to tackle the intermediate before we look at some of the other species down here.